guys, welcome back. And today we're going to be talking about glucose energy metabolism. And so this is actually involves three separate processes. So you got glycolysis, which is a series of 10 reactions that break a glucose down into a molecule called pyruvate. We got the Krebs cycle. And so what it's going to do is it's going to break that pyruvate down into smaller pieces, and it's going to store the energy in NAD and FAD and ATP, and then finally the electron transport chain. So it's going to use that NAD and FAD to move protons, and then it's going to allow the protons in to make ATP. You're like, oh my goodness, why on earth are we having all these crazy complex processes? Why can't we just use a glucose molecule to power chemical reactions directly? Why do we gotta go through glycolysis and Krebs electron transport chain? It would be just so much more simple if we just use glucose directly. Well, here's why. You guys are familiar with the game The Price is Right, and where the contestants have to get as close to the amount that this thing costs without going over. Well, in our body, things work kind of the opposite of the game of The Price is Right. So if The Price is Right, you want to get as close to the price without going over. With our body, you want to get as close to the price, but without going under. And once again, the price is paid in terms of energy. If we say glucose is $100 worth of energy, and let's say we have a chemical reaction that's going to cost us $1, and oh, by the way, there's no change in this game, how many chemical reactions could you power? Well, you could just power one. And so you'd have $1 worth of energy used to power this reaction, but then you'd have $99 worth of waste. When we waste energy in a cell, that's released in the form of heat. And so we'd only have a 1% efficiency right here. 99% of it is wasted. Option 2 is you use all these extra steps here. So what's going to happen is we got $100 worth of energy stored in the form of glucose, but we only get to store $43 worth of that energy in the form of ATP. Let's say our ATP, when we simplify it, we get that one ATP is storing about $1.04 worth of energy. Going back to our initial example, let's say they got a reaction, and that reaction requires $1 worth of energy, right? By the way, no change, right? So overall, how many reactions like this could we power? Well, we could power 32 of them, right? We're powering 32 times the amount of chemical reaction because we've broken this huge molecule worth of tons and tons of energy into much smaller energy molecules that aren't worth quite as much energy. And so remember, with our cell, it's the price is right. How low can you go without going too low? So if this molecule only has, let's say, 90 cents worth of energy, no go. This is not going to run. We need at least $1 worth of energy, and ideally just a little bit over right there, because that's going to make it worth its while. It's like if somebody were to tell you, hey, I need to go to the store and borrow these groceries for me, and it comes up to $100 worth of groceries, you're not going to go to the store for free. Well, look, I know you got $100 worth of groceries, but how much are you going to pay me to go to the store? And so they're going to have to give you a little bit extra to make you want to go. Same idea with the cell, right? This chemical reaction isn't going to be so excited about going if you have exactly $1 worth of energy. So you need to waste a little bit of energy in order for this chemical reaction to go. Now, that's not as bad as what it sounds, because once again, that wasted energy is heat. Well, we need a body temperature of 98.6. And so that energy you're wasting isn't such a big waste, because once again, it's keeping our body nice and warm.
All right, that concludes today's episode. If you liked what you heard, be sure to click the subscribe and like button down below. And as always, if you have any questions, comments, concerns, or if there's any particular topic you'd like me to create a video on, let me know in the comments down below. All right, well, I look forward to seeing you on my next podcast.